There is a person I want to describe for a moment, and there is a good chance you either know them or you are them. They do everything right. Up early. On the treadmill 5 days a week. They cut the obvious junk food months ago. They track their meals carefully, at least for the first few weeks. They feel the work. The sweat is real. The effort is real. And 6 months later, they have more belly fat than when they started. Not the same amount. More after all that work. The usual explanation is that they are lying. To their coach, to their app, to themselves, that they are secretly eating more than they admit. Here is the uncomfortable part. That is actually true. They are eating more. But the word secretly is doing something unfair here. It suggests they are careless. It suggests they are weak. It suggests that if they simply wanted it enough, they would stop eating. But there is research going back to the 1990s that tells a very different story about why this happens to so many people. It says your brain will push you to eat more and keep pushing until one specific nutritional need is met. Not calories, not carbs, one nutrient, one requirement. And until that requirement is filled, the pressure to eat does not switch off. It just keeps building quietly. If you never meet it, you can fight a diet for 10 years and lose every single time. Not because you lack discipline, because you are arguing with a control system that was built long before you were born and it does not care about your goals. This is not a fringe idea. It has a name. It has decades of evidence, and it started with insects in plastic boxes. Let me tell you what I want to cover, because there are a few pieces here and they build on each other properly. First, the discovery, where this came from, who found it, and why it took a scientist studying bugs to notice something about us. Second, the human evidence. Insects are interesting, but you are not one, and I am not going to hand you a bug study. Third, the actual number, how much protein you need, and the honest version of that number, because the internet version has been badly stretched. Fourth, and I think this is the most useful part, why your body cannot tell you what it actually wants. This explains a lot. Fifth, timing, what to eat and when. The order of your day matters more than most people realize, and it costs nothing to fix. Sixth, and please do not skip this one if you exercise, the workout problem. Training changes everything here, and getting it wrong can hurt you. And finally, the part almost nobody discusses. Protein is not the only nutrient that works this way. There are others, and that changes things. Let us start with the locusts. In the late 1980s and through the 1990s, a researcher named Stephen Simpson was studying locusts at Oxford. Not obesity, not diet, just locusts. He wanted to understand how they fed, what controlled their eating, why swarms behaved the way they did. Standard insect research, nothing to do with us. He and his colleague, David Raubenheimer, designed an experiment that sounds almost too simple to matter. It ended up changing how people think about appetite. They gave locusts foods with different ratios of protein to carbohydrate. Some were protein heavy, some were carb heavy, some sat in the middle. Then they simply watched what the insects ate, and how much of it and where they stopped. That was the whole thing at first. What they expected was reasonable. They thought the locusts would eat until they hit some energy target, then stop. That is the intuitive model. It is the model most of us carry around about ourselves too. Eat until you have enough energy, then stop. Simple, clean, obvious, that is not what happened at all. The locusts were not defending a calorie target. They were defending a protein target. Everything else was just whatever happened along the way. When the food was low in protein, they ate and ate. They massively overshot on carbohydrate. They took in far more energy than needed. They were not being greedy. They were chasing protein. The carbohydrate was simply the price of admission, and they paid it without hesitation. And when the food was rich in protein, they stopped early. They undershot on total energy because protein was satisfied before anything else was. Protein was not one input among several. It was the priority. Total calorie intake was just the leftover result of chasing that one nutrient. Simpson and Raubenheimer turned this into a framework called nutritional geometry, a way of mapping how animals balance several nutrient needs at the same time. Then they did the thing that made this matter to the rest of us. They ran the same tests across a huge range of species: cockroaches, beetles, spiders, fish, mice, rats, primates, animals separated by hundreds of millions of years of evolution, tested under the same conditions. Same pattern. Again and again. The protein target got defended, and total energy intake bent around it. That level of consistency is genuinely rare. And once you see that, an obvious question appears that you cannot unask. What happens if you dilute the protein in a human diet? Because that is more or less exactly what the last 50 years of food manufacturing has done to almost everything on the shelf. Here is the observation that turned this from a curiosity into a serious hypothesis about people, and it is a strange one when you notice it. Look across large dietary surveys from very different populations, different countries, different cuisines, different cultures entirely. Then look at what stays the same. The percentage of energy coming from protein barely moves. It clusters in a narrow band, often around 15%, almost everywhere researchers look. Fat and carbohydrate percentages swing enormously between populations. Protein does not. It sits still. It behaves like something being actively held in place. Which is odd, isn't it? If people simply ate whatever tasted good, protein should vary as wildly as everything else does. It doesn't. So the two researchers proposed what became known as the protein leverage hypothesis, and the claim it makes is fairly bold but quite simple. Humans regulate protein intake more tightly than we regulate energy intake. Protein gets defended. Calories are simply the collateral damage of that defense. When the protein density of a diet falls, we do not quietly accept less protein. We eat more total food until we get it. They tested this directly in controlled settings where people were fed diets manipulated for protein percentage and allowed to eat as much as they wanted. When protein was diluted, total energy intake went up. When protein was concentrated, total energy intake fell. The participants had no idea it was happening. They were not counting anything. They were not trying to hit a target. Their intake simply moved, and protein was the thing moving it. Then there is the study most people have heard a mangled version of, usually with the numbers inflated somewhere along the way online. Researchers put participants on a diet of 30% protein and let them eat freely. No calorie limit, no restriction. Just eat until satisfied. Compared with a 15% protein condition, those participants spontaneously ate around 441 fewer calories per day. Without trying, nobody told them to eat less. They simply stopped feeling hungry sooner, and they stayed that way. The change came from the food itself. Over 12 weeks, that group lost roughly 11 pounds, most of it body fat, with no deliberate restriction of any kind involved. I want to be careful here because this gets exaggerated constantly. That was 11 pounds over 3 months, not 13 pounds of fat in days. Nothing about this is a rapid transformation. Anyone promising that is selling you something. What it actually shows is far more interesting than that. It shows appetite is not a fixed force you have to fight. It is an output. Change the input, and the output changes by itself. Which brings us to the question everyone actually wants answered. How much protein do you need, and how much of the popular number is real? you will see one figure quoted constantly: 0.6 to 0.7 grams of protein per pound of body weight per day. For someone weighing 180 pounds, that works out at roughly 110 to 125 grams. That number is broadly reasonable. But pay attention here, because two separate areas of research get blended together, and the blend is where things go wrong. The protein leverage research is about percentage of dietary energy. It says protein takes up a defended share of what you eat, around 15%. It is not expressed in grams per pound. It does not describe a magic switch. It describes a pattern across populations and species. The grams per pound figures come from a different body of work entirely: trials on protein and fullness, body composition, and muscle retention while dieting. That research generally lands somewhere between 1.2 and 1.6 grams per kilogram of body weight for most active people. Converted, that is roughly 0.55 to 0.73 grams per pound. So the popular figure sits comfortably inside real evidence. Go higher if you train hard, if you are dieting aggressively, or if you are older, since we use protein less efficiently as we age. So the number is defensible. Just understand what you are doing when you use it, because the two pieces are being stitched together deliberately. You are taking a daily target from the fullness and body composition research and applying a principle from the leverage research about why hitting it matters. Both are real science. They are simply not the same study, and anyone presenting them as one seamless finding is smoothing over something important. What I would push back on hardest is the way this often gets framed online, as if there is one exact threshold and a switch. The idea that the instant you cross some number, appetite shuts off for the rest of the day is not how any of this works. What the evidence actually supports is more like a dial than a switch. It moves gradually. The pressure rises and falls rather than flipping. The further below your requirement you sit, the harder the drive to eat pushes on you. Close that gap and the pressure quietly eases off. Which is less dramatic, I know, but it is far more useful because it means partial progress counts. You do not need to be perfect. You just need to stop running a constant shortfall in the one nutrient your body genuinely refuses to negotiate on, day after day after day. And that leads directly into the part I find most fascinating, because it explains why this problem does not simply solve itself automatically. Here is the setup. You are under-eating protein. Your body notices immediately. So far, so good. That is the system working exactly as designed. Two things start happening at once, and both of them are well documented in the research literature rather than being anyone's speculation. In your brain, the hypothalamus registers a shortfall in amino acids and increases your overall drive to eat. That drive is not gentle. In your liver, protein restriction triggers release of a hormone called FGF21, which is one of the better studied signals in this whole area. FGF21 rises specifically in response to low protein intake. It acts on the brain to increase what researchers actually call protein appetite, which sounds perfect. Honestly, your body wants protein. It tells you to get protein. You eat something protein rich. Problem solved. Everyone goes home happy. Except that is not what happens, and the reason why is worth sitting with for a minute because it reframes an enormous amount. That signal is old. Very old. It evolved in a world where food arrived in whole, recognizable forms with nothing hidden inside them. Back then, the taste of a food told you something true about its contents. Meat tasted like meat. Fat tasted like fat. Sweet meant sugar. The signal and the substance matched. Your senses were a reliable guide. Following the craving actually led you toward the nutrient you needed. Now take that ancient system and drop it into a modern supermarket. Surrounded by products that were engineered by people who understand it very well. Modern food is built to be intensely rewarding to your senses while being nutritionally thin. Those two things used to travel together. Now, they don't. There are products that taste rich and savory and deeply satisfying that hit every cue your brain links with protein, containing almost none. Savory flavorings deliver the promise of protein without the delivery. Your mouth is convinced. Your body is not. Nothing about the requirement changes. So the signal goes out again. Your brain says, find protein. And you go looking, but your compass is being jammed the entire time. You reach for the thing that tastes the way protein should taste. It isn't protein. The requirement stays open. The signal fires again, louder. That is the loop. That is why people describe feeling out of control around food and then blame their own character for it afterwards. It is not a character flaw. It is a genuine biological demand being routed through a food supply that imitates the answer without providing it. And it explains something that otherwise makes no sense at all. How somebody can eat 3,000 calories a day and still be undernourished. The energy is there in abundance. The nutrient is not. So the system keeps asking, because from its perspective, nothing has been resolved. So how do you actually work with this instead of against it? This is where it becomes practical, and most of it is easy. Total daily protein is the thing that matters most. Let me be clear about that before anything else, because the details can distract from it. If you hit your target in one large meal at 9 at night, you still hit it. That is far better than missing it. But there is reasonable evidence that when you get it changes how the rest of your day feels. And adjusting timing is essentially free. Front load it. High-protein breakfasts have been studied fairly extensively, and one finding keeps appearing across those studies with reasonable consistency. People eat less later in the day, not just at the next meal, but into the evening. Reduced snacking, lower reported hunger through the afternoon. Now, the honest framing. This is not because a switch flips in your brain at 8 in the morning and stays off until bedtime. The likelier explanation is more ordinary. You start the day with the requirement partly met instead of already dug into a hole you must climb out of, which means the pressure never has a chance to build. Every decision afterwards is made by someone who is not being pushed by hunger. And decisions made under pressure are worse decisions. That is true of food, and it is true of essentially everything else in life. So aim to get a real portion of your daily protein into your first meal. 30 to 40 grams works well for most people, not a token amount of protein sitting beside a mostly carbohydrate breakfast. A proper serving. This single change does more than most people expect. Add fat to that first meal too. Fat and protein together slow digestion and support gut hormones like GLP-1 and CCK, which are real fullness signals. This is one of the better supported pieces of the whole picture. Eggs and avocado, fish, full-fat dairy, whatever you will actually eat consistently. For lunch, lean toward faster digesting protein. This matters most if you sit at a desk through the afternoon with snacks within reach. Chicken, fish, dairy, or a shake if you are short on time. It gets amino acids into circulation quickly, which is the point. That 3 o'clock slump toward the biscuit tin is very often a protein gap wearing the costume of boredom or tiredness. Worth testing. Push most of your carbohydrate toward the evening. There are 2 reasons for this, and neither one is about carbs being bad at night. First, If your protein target is largely met by dinner, you are choosing your carbs from a position of satisfaction rather than desperation. The difference between one portion of rice and unlimited rice is decided almost entirely by which of those two states you arrive in. Second, evening carbohydrate is genuinely fine for most people. The idea that carbs after dark are inherently fattening has been tested and does not hold. If anything, evening is when restriction feels hardest psychologically. So that is exactly where a little flexibility buys you the most compliance. On apple cider vinegar, since you will see it recommended constantly, let me give you the version that matches the actual evidence. Vinegar is acetic acid, and acetate is a short-chain fatty acid. There is real research showing acetate can influence appetite regulation in the brain. There is also decent evidence that vinegar taken with a meal blunts the glucose response afterwards, so the mechanism is not invented. But the effect on appetite in humans is modest, and part of what people experience as appetite suppression may honestly just be mild nausea. Take it if you like it. It will not hurt you. Just do not build your entire approach around it, because it cannot carry that weight. On salt, sodium appetite is a real and well-studied drive. It works on similar logic to protein, which is what makes it relevant. Your body defends its sodium status and will push you to seek salt when it runs low. That drive is surprisingly specific and strong. This matters most if you are low carb, fasting, training hard, or sweating heavily, because all of those increase how much sodium you lose. If that describes you and cravings appear from nowhere, low sodium is worth ruling out before concluding you have a discipline problem. Now the section I most want you to read, because this is where people who are genuinely doing everything right end up getting hurt. Go back to the person from the beginning. 5 or 6 days of cardio every week. More belly fat than when they started. Here is what is actually happening to them, and it is not mysterious once you have the protein piece in place. Exercise raises your protein requirement. This is not controversial. It is precisely why athletes are advised to eat more protein than sedentary people do. Training increases muscle protein breakdown and increases the demand for repair afterwards. The requirement goes up accordingly. That much is simply established. Now lay the leverage logic over the top of that, and watch what happens to somebody who trains hard but does not adjust their eating. Their protein target rises. Their protein intake stays exactly where it was. So the gap between need and intake just got noticeably wider. A wider gap means more pressure to eat. So exercise in someone not raising protein can increase total food intake rather than reducing it. And that increase rarely comes from protein. It comes from whatever is easiest and closest to hand, which is almost never a protein source. There is a second problem stacked on top of the first, and together they do most of the damage in this particular scenario. Exercise makes people hungry in a general, unfocused way. And there is a well-documented tendency to overestimate what a session actually burned. 40 minutes of moderate cardio might be 350 calories. A coffee and pastry afterwards can easily be 450. The maths does not have to be off by very much before the whole thing quietly tips in the wrong direction. Week after week. Put both problems together, and you get someone who trains hard, eats more, does not notice, gains fat, and concludes their metabolism is broken. Their metabolism is fine. Their protein intake simply never moved when their requirement did. That is the entire explanation. And it is fixable. So if you train, your protein target goes up. and you need to actually move it rather than assuming the old number still applies. Practically, that means adding somewhere around 25 to 50 grams on training days, with a decent share within a couple of hours afterwards. Not because there is a magic anabolic window that slams shut. That idea has been substantially walked back by researchers over recent years. The reason is simpler. That is the window when appetite is elevated. Filling it with protein stops the rest of your day getting away from you. If solid food straight after training does not appeal, a whey or casein shake does the job perfectly well. So do essential amino acids. Leucine, in particular, seems to carry a disproportionate share of the muscle-building signal. And there is some evidence it influences protein appetite too. I would treat those as convenience tools rather than replacements for food, though, because whole protein sources bring other things along with them. And one of those other things turns out to matter more than we thought. Which brings me to the last piece of this. Here is the idea that reframed all of it for me, and it is a question rather than an answer, which I quite like. If your body will drive you to eat until a protein requirement is met, why would protein be the only nutrient with that power? It isn't. Sodium appetite has been studied for decades and is genuinely specific. Depleted animals will seek out salt with real determination and precision. Calcium appetite has been shown in animals too. And there is human research, mixed and inconsistent in places, linking calcium or dairy intake with appetite. I want to be clear that this evidence is weaker than the protein evidence. It is suggestive rather than settled. Treat it accordingly. The broader principle is called nutrient-specific appetite, and it has been observed across a range of nutrients and a wide range of species. Your eating behavior is not governed by one dial. It is governed by several at once, each capable of pushing intake upward when low, which suggests something quite practical. Foods that satisfy several of these requirements simultaneously should be unusually satisfying for the calories they contain. And when you go looking for those foods, you keep finding the same short list, which is reassuring rather than suspicious in this case. Dairy, Greek yogurt, cottage cheese, whey protein, milk, high-quality protein, and a substantial calcium hit arriving in the same package together. Cottage cheese in particular is one of the more efficient options available if you are measuring satisfaction against calories. It is genuinely hard to beat. Small oily fish with the bones still in, sardines, mackerel, tinned salmon, protein, calcium from the bones, omega-3s, and a broad micronutrient profile. Nutritionally, these are close to unbeatable, and they are cheap, which is a rare combination in this space and worth taking advantage of. Eggs, consistently one of the best performing foods in fullness research, and high-protein egg breakfasts are among the more replicated findings here. Liver, occasionally extremely nutrient-dense. B12, folate, iron, retinol, copper once a week is plenty, because more is genuinely not better with liver. And here is a speculative extension, which I will flag clearly as speculation because I do not think it has been properly tested yet. If protein and sodium and possibly calcium each exert this kind of pull on us, what about the wider micronutrient picture more generally? Is some share of that persistent, undirected eating the kind where you are not even hungry actually a nutrient-seeking drive with nowhere to go? I do not know. Nobody does. Cleanly, it is an open question. And I would rather say that than pretend otherwise for effect. But the practical version costs you nothing. Eat nutrient-dense whole foods earlier rather than later, and take any multivitamin in the morning with food. Worst case, you have absorbed it better. Best case, you have removed a source of pressure you never knew was operating on you. Before the summary, a quick word on who this does not apply to, because that part usually gets skipped and it matters. If you already eat a genuinely protein-adequate diet, adding more will not unlock anything. This explains shortfall. It is not endlessly rewarding. If you have kidney disease or any condition requiring managed protein intake, this does not apply to you. Follow medical guidance instead of internet advice. And if food is a real source of distress for you, if targets and tracking tend to escalate rather than help, this framework may not suit you. That is worth being honest with yourself about and worth discussing with someone qualified. Regardless of how sound the underlying biology happens to be. For most people, though, the gap is real. Protein intake in many modern diets sits well below optimal, and closing it makes everything easier. So, pulling it all together into something you can actually act on tomorrow morning without buying anything or changing your entire life. Your body defends protein intake more tightly than it defends energy intake. When protein runs low, the drive to eat rises and keeps rising. Aim for roughly 0.6 to 0.7 grams of protein per pound of body weight daily. More if training, dieting, or older. Front load it. 30 to 40 grams in your first meal with real fat alongside it. A proper portion, not a token gesture toward it. Use leaner, faster digesting protein at lunch, especially if your afternoon is sedentary. That mid-afternoon craving is frequently a protein gap in disguise. Push most carbohydrate toward the evening so that when you arrive there, you are choosing your portion rather than chasing something you desperately need. If you train, raise the target. 25 to 50 grams more on those days, with a good share within a couple of hours. This is the single most common place where people accidentally undo their own hard work, and it is genuinely easy to correct once seen. Prioritize foods meeting several requirements at once. Dairy, eggs, tinned fish with bones, occasional liver. Take your multivitamin in the morning if you take one. And if you are low carb, fasting, or sweating heavily, do not ignore sodium. It is a small thing that causes disproportionate trouble. None of this is a hack, and I would be misleading you if I sold it that way. Nothing here shrinks belly fat in days. What it does is remove a pressure you have probably been fighting for years without knowing it existed at all. That is the real value. Which explains why so much of the effort felt harder than it should have. You were not just dieting, you were overriding a requirement, because that is the part I keep returning to. Everyone who has failed a diet has at some point concluded the problem was them, that they lacked something other people apparently had. And for a great many of those people, that was never actually true at all. They were running a chronic shortfall in a nutrient their body refuses to compromise on, and their body did exactly what it was built to do. That is not a willpower failure. That is a system doing its job properly, using the wrong information and reaching the only conclusion available. Give it the right information, and a great deal of what felt like a fight simply stops being one.